Okay, in this video we're gonna finish off the invader so it walks across the screen. Um, we've done all the hard work where in the previous video when we created that little custom layout code that we then made use of. Now, tidying up. So we've changed our code. Okay. Um, I've got all this code here from before. So these flash layout lines, I'm going to get rid of those because they're not they're not what I want anymore. Um, I'm going to put a few more comments on the end of this. What I tend to do when I'm doing this, more so in assembly language programming, um, is try and get tabs in the right place, so it's all nice and neat. It depends what your tab setting is in your. You'll find that if you load it in a different program, the tabs will be all over the shop. I don't what the tabs are in there. There might be four. You can generally change it if you go to preferences. You can change what the tab settings are. Um, yeah, so I just want to move it. So at the minute, the invader is using um, two states. So let's just have a look at two states. So let's load that up first. So two states uses the carrot thing and sends the bricks on um, to the character. And then the only other thing that two states, there's not much in two states. It's got this layout thing that which we're not even using now. Um, and I could effectively get rid of that. But it's got this action thing. Now what happens is the timer subsystem that's handled by game code, it sends to a level, it says, do you want to do any tick stuff? Do you want to do anything for this frame update? And it does that by calling the action code. Now, this is set in level set. So let's just look at level set. And you can see this is what happens. It tells the level to tick. And the tick goes, oh, if your time delay's up, then if there is um, a time delay, call the action code. Now, the action code's here. It's got nothing in it. But everything that inherits from level set, which is what character does, so you can see character inherits from level set, has got a chance to provide its own action. So you can say, oh, I want to do this action. I don't know what you're doing. So you can provide your own action. Now, character doesn't have one, but we, with two states, we inherit from character, but we want to provide an action. Now, what we do is we then, at the start of ours, we say, right, let's call the other actions that have been defined in the superclass. And that's what this super dot means. So we're saying call the action for the superclass. So the superclass for two states is character, but we've just said in character there isn't one. It's not defined. Action's not defined. So what the JavaScript subsystem does, it goes, oh, hang on a minute, character was based on level set. Let's go right down to level set. And it will run this one, even though it doesn't do anything. But what we've got to be aware of is that when we build things, it might be that there's something else happening. Okay, so if we look at two states, it does some flashing. This is the thing that makes bricks that are visible invisible and bricks that are invisible visible. And it does it with this line here. It processes all the bricks and it just says that. It says whatever they look up the visibility of a brick, apply not to it. So if it's true, make it false. If it's false, make it true, and change the visibility to that. So it's a toggle. And this action thing is every time the tick happens. So if we look back at invader, if I can find invader now, my eyes are going. When we call the constructor and we call the super constructor, which is the constructor for two states, we give it this value 1. That's our time period for the flashing. So if I set that to 0.1, so just to show you this, and then we'll get on and we'll build the movement bit. If I save that and then go back to Chrome, I'll leave the debugger open, but I'll flash it now. It's going to animate every 10th of a second. And you'll see that once the get ready's gone. Okay, so I think the limit on the thing is 20 milliseconds. So let's let's just go stupid and set that to 20 milliseconds. So once every frame, it's going to flash. So let's just save that and see how stupid that looks. But that's as fast as you're going to be able to animate. So as soon as the get ready goes, the animation will start. You'll see that, yeah, it's every other frame. You get a sort of transparency effect. So you could actually do some really cool effects by doing, and you do see this animations like these in games. You get nice cool effects. But anyway, that's how we set that up. So let's put that back to 1. So we are going to get an action called um, every 1 second. So let's add an action here for us. So we're going to say, so I'm just doing this below the constructor. You see, there's no other code in this invader. This is object-oriented programming. This is one of the benefits of it, is that you're only adding the extra code you need. The other code's already written already in another class that you've inherited from. Right, so we need to accept the delta parameter, even though we're not going to use it. So I've created a skeleton. Now, the first thing I always need to do if I'm doing something that's inherited and there's an action there, I need to call the super of it. How you do this is different in different languages, but this is how it's called in JavaScript. Super dot, and then we say, right, well, pass the delta on to the other one. Okay, and then we need to write some code to move the blocks. Now, in Space Invaders, the Space Invaders move a pixel. So every time they animate, they move a pixel. Now, in our case, we've made our pixel 25 pixels in size. So we want it to move 25 pixels. So it moves an entire block. So the first thing we need to do is, how do we process and move all those blocks? Well, the blocks are in an array called bricks. So what we're going to do is a standard algorithm, which we'll do millions and millions of times. We're going to use a for loop to process an array from start to finish. So we do this by using the for statement, and we create a variable. We tend to traditionally call the index variable I, and we start it at 0. So we look at the first brick. And then what we want to do is we want to make a loop that goes through every single brick. So we say, right, start at 0, keep going while the value of I is less than bricks.length. Left, not left, length. I wasn't looking at the screen when I was typing then. I saw the L come up and I just pressed enter. So we're saying make a loop, starts at 0 and works all the way down to the end of the brick array. And after processing each brick, move to the next one. So we say I++. So this is a standard loop, standard classic computer science loop for processing an array. Right, now we've got to decide what we do in there. So we want to move them. So let's try it. So we're going to say this.bricks. So that's the name of the array, but we want a specific brick. We want the brick that is indexed or referenced by the position or the value of I. And we want to do an operation on that brick. And there is an operation that we built into Sprite. So let's just quickly show you that if I can find Sprite, called move. I don't know whereabouts it is. Being here, so move. And we can specify an X and Y value, and it repositions by that amount. You can see it adds it on. Okay, so back in Invader. So I'm going to say move, and I want it to move to the left. So that's a negative value. So I want it to move 25 across, but I don't want its height to change. Now there's nothing to stop me making the height change. So I could make it walk off screen, but I'm not going to, I'll leave that as an experiment for other people. That would actually be quite cool, actually. If once the last brick is gone off the screen, drop the invaders down, but and doesn't matter. Right, so I'm going to do that. So let's just review what we've done. We've created a new action, but we know there are actions from classes that we've inherited from that need to be called. So we put super.action. And then we say, right, okay, set up a loop to process all the bricks and move them all 25 pixels to the left. So let's just save that and let's run the game and see what happens. I'll change that thing back to 1 second so it won't be doing that. Right, so it's going to flash, and as it flashes, it's going to move. So let's just see what happens. Every second. Oh, look at that. That is so good. Remember, I've still got the demo time. I've only got the demo time. Let's just play the game. I think I've got the bricks aren't destroying. I think I've got the ball bouncing, so I don't have to worry about catching the ball or anything. I think I've got it bouncing. Yeah. So I've still got those two global variables set. And there you go. And it's gone. It's walked off screen. Right. So what I want it to do, I want it to come back on the other side of the screen. So we've got one more thing that we can add. There's loads of ways of doing this, but I've built a little system. So I'm just going to check and get each brick after its moved position. So bricks, that's a square bracket, by the way. I'm going to tell it to wrap. So that calls a function. I think that's in moving sprite, that one. That calls a function, is a wrap. Oh, it might be in normal sprite. Yeah, probably is in normal sprite. Wrap, there it is. And it just checks. I could have actually done wrap X. Um, but it just checks to see if we've gone off the edge of the screen, and it plops us on the other side of the screen. Okay, so that's all it's doing. So back to invader. So all I'm doing is move it, and it's important that I do this in the right order, that I get my sequence correct. So I do the move, then check to see if it needs to be repositioned. Okay, let's just save that and see what effect it has. Hopefully it has a good effect. So I'm going to refresh. I'm going to play the game so it lasts for more than 10 seconds. And there you go, they come back on screen. Now, one thing I've noticed is that they're not smoothly coming onto the screen, so I don't like that. So I think I'm gonna, I don't know, I think it's a product of them moving in big steps. I don't know. Is it aesthetically pleasing? Wonder what happens if we go the other way. Let's just change the movement to positive, so they move to the right. Let's save that. I don't know. I don't know whether I like it or not. Start the game. So press 1. Right. So it's going that way this time. So when it goes off the edge of the screen, yeah, it's because they're moving in steps of 25. So it's never going to be smoothly on the screen. That's just how it is. I don't know which way I like them going actually. Um, yeah, but again, you're seeing the debug things. I know it's not bouncing properly, but you can see that the level's working and it allows us to test it without having to worry about catching the ball and everything. Okay, so let's just look at what I did. So yeah, for that one, I just put an action on to move the bricks, or for the time period. Now, I can do lots of other things here, and I can keep track of this delta value myself and have like a animate at a different speed. So I'm running off the animation speed, which I set to a second. But there's nothing to stop me um, making big changes to this and keeping track of timers myself and things to do other effects. Um, but yeah, like I promised, that's how you create an animated invader. The final video I'm going to do is just going to show you how to create um, a level from scratch. I'm going to use the character one for these block maps because the block maps gives you a little bit more flexibility on how you position things and lay things out. But I just want to show you how to create one from scratch so you can inherit. And I'll do a couple of different types. I'll do a block map one and I'll do a standard level one as well. Okay, thank you very much.